Welcome to our video that's going to be a very quick review on how to compare fractions. So there's two ways that you can compare fractions. Let's take our first example here. Let's say I was comparing the fraction 2/3 and the fraction 3/5. It's very difficult to compare the fractions in their current form. So I have two options. My first option is to change the fractions so that they have a common denominator. And I'm going to choose the least common denominator that I can. So since I'm working with 3 and 5, I'm going to choose 15. So if I have 2/3 and I want to change it so that the denominator is a 15, I would have to multiply both the top and the fraction by 5. So 3 times 5 will get me the 15 in the denominator. And since I multiply the bottom by 5, I multiply the top by 5, and that will give me 10. I'm then going to do a similar thing with my second fraction. I start off as 3/5. I also want to have a denominator of 15 here. In order to get 15 in the denominator, I multiply by 3. So 5 times 3 is 15. Since I multiplied the bottom by 3, I must multiply the top by 3. 3 times 3 is 9. And at this point, I can simply compare my fractions since they have the same denominator by looking at their numerators. 10 is here, and I have 9 over here. 10 is greater than 9, so 2/3 is my larger fraction. Another way that I could do this is I can rewrite the fractions as a decimal. So change the fractions to decimals before comparing. So I'm going to use the same examples here, and keep in mind when we change a fraction into a decimal, we simply divide the numerator by the denominator. Ooh, that's not very helpful. So my first fraction was 2/3. So in order to make that into a decimal, I'm going to set up my division problem. And the 2 is going to jump inside the pool. The 3 is going to stay outside. 3 cannot go into 2, so I will add a decimal and a 0. And I'll bring my decimal straight up. 3 goes into 26 times. 6 times 3 is 18. I subtract and get a 2. And I quickly realize that this is going to be a repeating decimal. So I'm going to write it over here as 0.6, and I will use bar notation to show that the 6 does repeat itself. My second fraction that we were working with was 3/5. So similarly, I'm going to make 3/5 into a decimal. Again, divide the numerator by the denominator. So the 3 is going to jump into the pool, the 5 will stay out. 5 cannot go into 3, so we add a decimal and a 0. Bring that decimal straight up. 5 goes into 36 times. 6 times 5 is 30. I subtract and I get 0. So this is actually a terminating decimal. 3/5 is equivalent to 0.6. Now, this is going to be interesting to compare because if I look here, I have a 0 in the whole number in both places. I have a 6 in the tens place in both numbers. But keep in mind, since this is a repeating decimal, I'm going to have a 6 in the hundredths place here. Over here, the only digit that I could add on without changing the value of the decimal would be a 0. And 0.66 is larger than 0.60. So again, that proves to us that 2/3 is the larger fraction. So again, before you can compare fractions, you have two choices. You can either make them so they both have the same denominator and then compare their numerators, or you can rewrite them as decimals and then compare their decimal values.